Hello, grade 12. So we're going to continue with parallel line theorem. I'm working from slides 29 to 32 from the PowerPoint proportionality. So we're going to be going on to example 4. I'll just read it out to you. It says, in triangle ABC, we have that AB is parallel to FD and AF is parallel to DE. If FE to EC is 3 to 4, determine the ratio EC to BC. So we want to find this EC to BC. Okay, so what I'm going to do is I'm just going to mark a couple of things before we start. Okay, so this I'm going to mark in green. So we know that FE to EC is 3 to 4, sorry. 3 to 4. Okay. I'm just going to continue marking things and then I'll start getting onto the statement reason stuff and then we can just see where we're going with this. So from this, I can see with this parallel line and that parallel line, I beg your pardon, this one and this one, we can say now that this to this. You see, if I block that up, we've got this to this, that to that. That will also be 4 to 3. Okay. But if we now use this parallel line and this parallel line, we can get that this to this will be that to that. Okay, so we now know that that's 4, this will be 4, that's 3, that will be 3. So this is very similar to that example that I did yesterday where we're getting an overlap of proportions, and I'm just talking about this section over here. As you can see, we have 4 to 3, but then this whole thing is 4. Okay, so don't get confused, grade 12s. These are not lengths. So you can't say, oh, but this says it's 7 and then that says it's 4. It doesn't work like that. These are proportions. Okay, so let me start writing some of these things that I've just written there, and then we can start moving on to this. So first of all, what we're going to say is we're going to say that CE to EF is equal to 4 to 3. So CE to EF is 4 to 3. Okay, and that was given from here. Okay, the next thing, therefore, CD to DA is also equal to 4 to 3. That's what we did over here, the CD to DA. Okay, and the reason for this, line parallel one side triangle. I'm just going to list the parallel lines that we used because we've got multiple ones here. So the ones that I used was this one with this one. So it's DE parallel to AF. Okay, so what did we do from there? So then we went to the other side. Then I said that CF to FB was 4 to 3. So therefore, CF to FB is equal to 4 to 3. And what I used there is I used the other set of parallel lines. I used this DFAB one from there to there, there to there. So line parallel one side triangle. But I used a different set of parallel lines now. I used DF parallel AB. All right. So now what we want, if we go back to the question, we want EC, BC. EC, BC. So what I want to do now is I want to find EC on its own, okay, in terms of the orange bits. You see, because we have BC in terms of the orange, it'll be 7. But what is EC in terms of the orange? And now this is where it comes with the overlap of your ratios. So what I'm going to say here is I know that CE to CF in terms of the green, okay? So CE to CF. And why am I saying CF? Because I know CF in terms of the orange, and I want to get the CE on its own. So we know that CE over CF is equal to, now if I have a look at the green, it is CE is 4 over, and CF is 7 parts. 4 and 3 gives you the 7. So what I've done here is I've compared the two. So this is my orange bit, CE to CF, the orange bit. And then this 4 over 7 is the green bit. Okay. Now, in terms of the orange bit, I know what my CF is. My CF is 4 parts. So we get here CE over 4 is equal to 4 over 7. Okay. And I have got now CE from the orange bit, and I can get it on its own. So now we can say that CE is equal to 16 over 7. And remember that this was the orange one from there. Okay. Now, grade 12s, as I spoke about it yesterday, we should put a little k here and then a k over here for your constant of proportion. I'm not going to do that. It is going to confuse you guys, and I'd rather just keep it simple just like this. Okay. So, moving on. Now, I know that EC, this one, CE, to BC. I have the whole thing in orange now. So, this EC to BC will be equal to, so the EC part in orange, we worked out is 16 over 7. And the BC part in orange is 7. 4 and 3 gives you the 7. I can simplify this and we get EC to BC is equal to 16 to 49. And we have solved it. Okay, moving on to example 5. Okay, I'll just read it out to you. It says, prove that a triangle CEA is isosceles. So CEA, that triangle is isosceles. Then question B, we have to find this, we have to prove that BD to DC is equal to AB, AC. Okay, so we'll get to that one in a second. They've also given us that this angle is X and that angle is X there. All right, so let's try and prove that this one here is isosceles. First of all, I can see that this angle here will be equal to that angle over there. And the reason is alternate angles. Okay, don't worry about me writing it just yet. I just want to fill in things and then we can fill it down here. Okay, so we've got that one angle. Now, this angle here will be equal to this angle over here. And that is corresponding angles. Okay, and I think we pretty much proved that it's isosceles now. We've got this is equal to this, so this side will be equal to this side, and we've proved it. So let's start writing it down. So I know that angle C would be equal to, if I call this A1, 2, and 3, just so we know which ones we're talking about. So angle C is equal to angle A2, which is equal to X. All right, and that was alternate angles. And the parallel lines I used was EC parallel AD. The next thing that I proved was angle E is equal to angle A3. And that was equal to x. And for this reason, it was corresponding angles. Again, it's the same parallel lines, EC, parallel AD. All right, so therefore, angle C is equal to angle E, which is both equal to x. Okay, therefore, this AC side will be equal to this AE side. And it is sides opposite equal angles. Okay, therefore, we've now proved that this is equal to that. Therefore, triangle CEA is isosceles. Okay, moving on to question B. Now, with question B, I'm going to use my parallel lines. So I know that BD to DC would be equal to AB AE. Okay, line parallel to one side of the triangle. Now, how does that help me? So if we have a look here, we've got the ABAC, ABAC. Okay, so that one's a little bit tricky. Then we've got BD and DC. Cool, so we've got that. BD, DC is this one. But have a look at this side here. This AE is equal to AC. And there we have it. We have the AB, AC, AE, sorry, is AC. And that's how we're going to do it. So we know that BD over DC is equal to AB over AE. That's the green that I've just done. And it is line parallel one side triangle. The parallel lines that I used was DA, AD, parallel EC. Okay. Now, what do we know? We know that this AE is equal to AC. We just proved it over here. So BD over DC is equal to AB over, and it's AC. And we have proved it. Okay, thank you, grade 12s.